Now we will see the last important step in this chapter, using DTC freeze frame data for RCA. Now, as we spoke about the troubleshooting methodology, I also said that analyzing the DTC frame is an important step when it comes to root cause analysis, and we will elaborately see that step in this particular lesson. In the electric vehicle diagnostic system, using DTC freeze frame data is a powerful method to perform root cause analysis. Okay, especially during the fault tracing. It offers a snapshot of critical system parameters at the end moment. Uh, a diagnostic trouble code was triggered, helping engineers and technicians identify not just what failed, but why and under what conditions. I mean, what were the exact at given moment at the moment conditions when it failed. So, well, I already elaborated you what is meant by DTC, so I will not go into that. I just remind you that think of it as a black box. All right. So, what is its purpose in root cause analysis? First of all, in this table, we'll see the question and how freeze frame helps. So first you understand what failed, shows the DTC and associated system. And next is when did it fail, timestamp or driving condition, under what condition. All right, the voltage, current, and temperature, speed, etc. Now, was it an isolated case, repetition of pattern and multiple frames, and can it be reproduced? Helps in simulating exact failure conditions. All right. So during the actual root cause analysis, DTC frame answers helps to answer all these questions. That's the reason it is so important. Now, what are the key parameters in freeze frame data? When it comes to parameter, we will talk about the parameter and also the typical freeze frame content. So first is DTC code. Well, it involves the numbers, the alphanumerical name. Next is when it informs the state of charge, whether it is a BMS specific fault or not. Next, it talks about the HP battery voltage, current, charging or discharging status. When it comes to inverter temperature, thermal related failures. Okay. Next, talking about the motor speed, load, and stress status. Now talking about the charger input voltage current for OBC or fast charging issues. Now coming to the ambient temperature for thermally induced faults. Next, when it comes to vehicle speed, context using during driving faults, isolation resistance for HV safety related faults, and HV interlock status, open loop or connector issues. So these are the parameters and these are the freeze frame contents. All right. So these are, with the help of this content only, you start the root cause analysis. Now, how to use freeze frame data in root cause analysis, we'll see step by step. First, you retrieve the DTC and associated freeze frame, and you use diagnostic scan tool, UDS, OBD, OEM tool, and then you access the fault memory of the relevant ECU, and also you note the DTC subcode and all freeze frame parameters. All right. Now, talking about understanding the context of failure, for example, DTC P0D26 charging fault, system fault. At that time, you know the charger input, you understand the battery voltage, you understand the current, you understand the CP signal duty, you understand the temperature. So, what is the interpretation of all this data? This interpretation is vehicle was connected to charger, but EVSC communication failed. So, fault likely external or at communication protocol interface. All right. So this is one way you extract or deduce where the fault is. Now, sometimes you have to correlate multiple freeze frames if available. So some ECUs support storing multiple snapshots, first occurrence, last occurrence, and most recent. This allows you to detect fault pattern recurrence and compare operating environments for consistency and determine if it is a intermittent or persistent fault. All right. Now talking about reconstruct the fault scenario. Talking about the reconstruct the fault scenario, use freeze frame data to simulate or replicate the fault under controlled conditions. All right. So when you what do you do when you reconstruct the fault scenario? You replicate the same SOC, the same charger, the same load, the same temperature, and this is critical for validating if DTC was false positive or systematic. Okay, was it some kind of a fake alert or was it a systematic? This step of reconstructing the fault scenario clearly indicates. Okay, hope you are all understanding and following. Now, talking about the drill down by system type. When it comes to drill down by system type, the battery management system P1A10 cell voltage imbalance, and next is freeze frame. First of all, you note down the DTC and then the freeze frame. At the freeze frame, SOC is 55%, cell 1 3.72 volts, cell 2 is 3.92 volts, and temperature is 30 degrees centigrade, current is 88 discharge, and insulation resistance is okay. So, what is the root cause analysis insight? The insight that is deduced or inferred is cell 1 is underperforming, fault occurs under moderate load, possible cell degradation or poor bushbar contact. Now, talking about the motor and inverter system, again, first of all, you identify the DTC, in this case P0A92 motor A performance. And talking about the freeze frame, well, these are all the various parameters at the given moment: motor speed, torque, battery voltage, inverter temperature, and coolant temperature. So what is the RCA insight? So most probably inverter likely went into thermal derate mode or protection shut off due to overheating. So naturally, when temperature has reached up to 90 degrees centigrade, so most probably inverter felt that it is a overheated, it is overheated, and then it went into thermal derate mode. Now talking about the onboard charger. When it comes to onboard charger, well, this is the DTC P0D3A charging communication fault. This is the freeze frame. When it comes to freeze frame, these are all the parameters that have to be noted. Now, after seeing these parameters, what is the RCA insight? CP signal is out of valid range. Issue likely external EVSC or CP signal path circuit. Okay, so this is the CP signal path circuit on the onboard charger. Now talking about the thermal management system, talking about DTC P0C73 battery cooling flow fault. Now talking about the freeze frame. Again, for every domain, you understand this free frame is of extreme importance. RCA insight, pump is commanded on but no flow. Mechanical blockage or pump failure. All right, so this is the most probably the RCA insight. Now I hope you understand that I'm always using words like likely or most probably or most probably, because based on one freeze frame it is usually very difficult to identify the root cause. But just for sake of demonstration, I'm trying to tell you why the freeze frame is so important when it comes to understanding the RCA insight. You understand? All right, hope all of you are understanding. So what are the best tips, worst practices when freeze frame for RCA? All right, now we will see the tip and why it matters in the below table. Always correlate freeze frame with live data. Freeze frame is static, live data shows trends. All right, and also important tip is don't rely solely on DTC. DTC is definitely an important clue or a hint to understand the fault, but relying solely on DTC can be slightly foolhardy. All right, because the root cause might lie in a different subsystem. This is what I touched upon. Okay, depending upon the complexity, sometimes root cause may lie in the other subsystem. That is the reason why it may not be so checking one DTC may not be the optimum thing to do. Compare with the baseline values, know what normal looks like for your EV model. Check for a time, date, and mileage tags. Understand when and how often it happens. And also document every snapshot. So critical for field service reports and audits. Okay, now talking about the summary, benefits of using freeze frame for RCA. So we are going to see the benefit and the description. First is of course the faster diagnosis. So as I said, this is a very important clue in understanding the root cause, and this pinpoints the faulting conditions. Next is contextual analysis. You clearly understand under what context the fault happened. So it constructs the environmental operational environment, where exactly, when exactly, under what circumstance exactly the fault happened. It clearly indicates. Now talking about reduces guesswork, minimizes random checks and blind part replacement. Talking about, it supports systematic RCA. Now I have told systematic and random RCA. Now freeze frame plays a very important role in systematic RCA. It integrates with structured methods like fishbone or five eyes. So in case you are implementing these methodologies like fishbone or five eyes, this is an extremely important use case. Now talking about improves field data feedback, it helps design better diagnostics and validation plans. Last but not the least, it clearly helps design better diagnostics and validation plans. All right. So hope all of you got an overview about the role of freeze frame in the overall diagnostics and in the overall root cause analysis. Thank you.